So the lesson today, okay, is going to be the continuation of our lesson yesterday, okay, which is going to be redox reaction. Now, if you look at redox reaction, okay, redox reaction can be divided into oxidation and reduction. Okay, so redox reaction is going to have both oxidation and reduction happening at the same time. Okay, so whenever we want to actually identify, okay, a reaction is going to be redox or not, okay, we can use certain criteria, okay, that will help us to identify whether it's going to be oxidation and reduction. So there are 4 criteria, okay, that we can use, okay, to identify, okay, and then out of those 4 criteria, okay, one is not so important, yeah, and the remaining 3 are very important. So let's look at that 4 criteria. Okay, the first criteria is going to be when there is going to be addition of oxygen atom. Okay, and this addition of oxygen atom, okay, is going to tell us that oxidation is taking place, and removal of oxidation oxygen atom is going to tell us that reduction is taking place. And the second criteria, okay, is when you have increase in oxidation number. ON is oxidation number. Let's say the number is increasing, okay, therefore, okay, we can say it's oxidation. And, okay, reduction is decrease in oxidation number, okay. And the third one, okay, is related to this oil rig, okay, which is going to be related to electron, okay. Oxidation is loss of electron. So whenever there is going to be loss of electron, it is going to be said that it's going to be oxidation. Whenever there is going to be gain, reduction is gain of electron, then it's going to be reduction. And, okay, the last one is going to be, you see, plus, plus, minus, minus, this is minus. So this one will be minus. If there is going to be loss of hydrogen, okay, we say is going to be oxidation. Whenever there is gain of hydrogen atom, then it's going to be reduction. But for the fourth one, which is going to be the hydrogen, okay, this hydrogen atom, normally we use it for organic reactions, okay, the one that involves hydrocarbon and so on. So therefore, maybe this one is not so important. Okay, but the one that is most important will be the first 3 definitions. And we can use any of them, okay, to identify or to help us to identify whether it's something is oxidation or reduction. Okay, for example, okay, if we have a reaction, if we have this particular reaction, copper oxide using hydrogen changing into copper plus H2O. Okay, now this reaction, okay, we want to find out whether it's going to be oxidation redox reaction. First of all, okay, we need to find out, okay, is there anything that is being oxidized or not? Is there anything that is going to be reduced or not? Okay, so in this case, okay, if you look at this, okay, copper, okay, there are 3 ways to identify, okay. But out of these 3 ways, okay, the one that involves electron, we tend not to use it, yeah, because electron, it will be more suitable if you have half equations and so on. So now we have 2 methods that we can use. One is related to oxygen atom. Another one is you can use the oxidation number, okay. So if you look at this, okay, some students actually wondering, sir, why we are using the oxidation number of copper? Why we are not using the oxygen and oxygen? Normally, oxygen, okay, I told you, oxygen is always -2. Okay, they are not going to change. Okay, so that is the reason why we find the oxidation number of copper. Okay, why we are using the copper. These are the 2 combinations that we are going to use. Okay, one is related to copper, another one is related to hydrogen. So we need to find out, okay, whether which one is oxidized, which one is reduced. Now, if you are using the oxygen method, you can see copper oxide is losing oxygen. Okay, copper oxide, okay, to become copper, they are losing oxygen. So are they going to be oxidation or reduction? Losing oxygen, reduction. Okay. So this is reduction. But if I want to actually look at it in form of oxidation number, okay, how do I look at it in form of oxidation number? What is the oxidation number of copper over here? So how to find? Okay, I told you, okay, that when it comes to oxidation number, okay, there are certain criteria, okay, certain guidelines that we need to follow. So what are those guidelines? Okay, number one, okay, we need to know that all elements, okay, all elements, the oxidation number is going to be 0. Okay, that's the first thing. Second, okay, if in compound, okay, if it is compound, okay, if you have group 1, then they are going to be oxidation number is 1. Group 2, oxidation number is going to be +2. If you have group 7, then oxidation number is -1. Generally, we follow the something like your charge. Okay, and within that compound itself, okay, oxygen, there are certain things that you can remember. Okay, oxygen in a compound. Okay, oxygen is always going to be -2. Okay, let's actually talk about something that is always first. Later, I'll come into exception. Okay, when it comes in a compound, hydrogen is always going to be +1. Okay, always. Okay, and then when in compound, okay, it is mentioned in your textbook also, fluorine is always going to be -1. But I just told you also, okay, whenever in compound, okay, generally like Cl and so on, most likely they are going to be also -1. Okay, because group 17, yeah, so they are going to have -1. So these are general, okay, but there are certain exceptions, okay. So what are the exceptions? Okay, the exceptions are, okay, oxygen, okay, they have 2 exceptions. Okay, what are the exceptions? One, if they have, okay, hydrogen peroxide, okay, then, okay, they are going to be, the exception is hydrogen is always +1. So if you have H2O2, 2 times +1, okay, plus, okay, let's say this one you put as x, 2x, total is 0. So 2x is -2, x is -1. Okay, so you have oxidation number. Okay, for this, oxygen is going to be -1, not -2. This is one of the exception. Another exception is related to F, which is whenever you have F2O, the oxygen is going to be different. Why? You can calculate also. F2O, they have mentioned that F must be always -1 in a compound. So -1, okay, times 2 plus this one I put x equals to 0. Don't ask me why it's not -2, because I'm trying to show it's different. Yeah. So here -2 plus x equals to 0, x is +2. So oxygen is going to be +2 over here. These are the exceptions for oxygen. Now, there are exceptions, okay, for hydrogen as well, okay, where, okay, hydrogen is always +1, but if you have metal hydride, for example, NaH, okay, this is called metal hydride, okay, so if you have that, okay, we know that NaH, group 1 in a compound, okay, they have mentioned that group 1 in a compound is +1. So if this is +1, okay, so +1 plus x, overall is 0, x is going to be -1. So you can see that the hydrogen now is -1. This is another exception for hydrogen, okay, and so on, okay. So these are the common ones, okay, common ones. So I didn't write everything, okay, I just put, okay, there are certain things, okay, when it comes to compound. Now, for number 3, okay, is the one that we have been using over here. In a compound, if it is going to be a neutral compound, the overall charge is 0. You see, I use 0, I use 0, I use 0. So it means a neutral compound, okay, the oxidation number, okay, is going to be 0. The entire, okay, for the compound, okay. So number 4, if we are talking about ion, okay, then the ion will follow the charge. Let it be a single ion, let it be a complex ion. Okay, so ion, okay, will follow the charge. So when do we actually look at it? Yeah, some example, okay, ions that follow charge. As simple as, let's say we are talking about Cl minus, the oxidation number is -1. Okay, and maybe as simple as Br minus, oxidation number is -1. But if you go complicated a bit, okay, for example, if I have MnO4 minus, okay, it means that the total oxidation number of this entire thing is going to be -1. Okay, and similar, okay, if I'm talking about Cr2O7 2 minus, okay, the total, okay, oxidation number is going to be -2. Okay, and it can be used for many things as well. Okay, not only limited to this. Okay, now using this rule, you can use it for many things. Okay, example, okay, let's say I give you one example, NaOCl. Okay, and then, okay, they ask you, okay, find the oxidation number of Cl, for example. Okay, find the oxidation number of Cl. Now, there are two ways to do this, okay, but the best way, okay, what I suggest you to do is to separate them. Not all the time you can separate, okay, please understand, NOCl, you can separate them into their ion, Na plus OCl minus. Okay, it's not the other way around, okay, it's Na plus OCl minus. It means that this overall charge is going to be -1. You do not need to calculate for everyone. Okay, if you want to save time, okay, you just take, okay, and then from here, you want to find out what is the oxidation number of this. So what you do is -2, you put plus X, overall is going to be -1. And X equals to -1 plus 2, it will become +1. So you notice that Cl is not always -1. Okay, so you can find the oxidation number from that way. Yes, okay, that's why in a compound, okay, in this part last time, okay, they have already mentioned group 1, group 2, okay, in compound, they are always +1 and +2. Okay, so if you want to do it straight away, also can. Okay, so straight away is NaOCl, this is +1, okay, this is -2, and this is X equals to 0. Okay, and then it's -1 plus X equals to 0, X is going to be +1, it's still the same. Okay, why I am teaching you this method? Because in future, okay, we are going to learn, yeah. Oh, you want to see that? Sorry. So in future, okay, when we are looking at, okay, acidified potassium manganate, okay, and in future, if we are looking at acidified potassium manganate, acidified potassium dichromate, okay, if they ask you find the oxidation number, okay, of let's say manganese, Mn, and chromium, Cr, okay, rather than calculating the entire thing, you can separate them to K plus and MnO4 minus. Separate them first, okay, and then you find out X plus 4 times -2, oxygen is -2, equals to total is -1, X minus 8 equals to -1, X equals to -1 plus 8, you will get +7. So you no need to include the K. Separate them, easier. The same over here. This is 2K plus, okay, 2K plus, and then Cr2O7 2 minus. Okay, separate them. And then you want to find for this, okay, just put 2 times x plus 7 times negative 2 equals to overall is negative 2. And then you find what is x. Okay, so 2x negative 2 plus 14, x equals to plus 6. So CR is going to be plus 6. That's why, okay, when we write, okay, acidified potassium, we call it acidified potassium manganate 7, because 7 tells you the oxidation number of Mn. And we call it as potassium dichromate 6, because 6 tells you the oxidation number of Cr, okay? This is the same, okay, when we apply towards, okay, some simple examples, which is going to be if I have, okay, CuO, Cu2O, FeO, Fe2O3. If I have A, B, and assume this is going to be ionic compound, AB, okay, is built from A plus and B minus. Okay, must be the same. That's why it's AB. But if you have A plus and you have B2 plus, okay, what do? We try to make the charge the same. Okay, so this is plus 2, this is plus 1 only. You need to make it plus 2. Sorry, this is 2 minus, okay. So we need to make it into plus 2. How do we make it into plus 2? I times this by 2. So if I times by 2, it means I require 2 A plus. So it's supposed to be A2B. Okay, now this is easier to understand. Okay, the problem that you have now is to bring this to go back there. Okay, that's why you're always asking, how do I know this? Okay, the problem is there. So now if you have A to B, okay, my suggestion is to look at it in this way. If B is negative 2, okay, you require 2 something, 2A. It means A must be, okay, 1. Then only I need to times by 2. Okay, so then only I times by 2. So the oxidation number of A is plus 1. So now if you have K2 Cr2O7, okay, it means that K is plus. Okay, we know K is plus. And you require 2K. It means you have 2 plus. So of course this one must be 2 minus. Then only you have K2 Cr2O7. Yeah. So this one is just the other way around only. Yeah, quite simple to understand. If we look over here, okay, which is going to be, okay, there are 4 examples. Okay, first what we want to know is to find the name. Okay, and later, okay, I will rewrite again. We will try to write down, okay, the formula using name. Yeah. So now, okay, we want to find out what is the name. Okay, so you see Cu and O. First thing that you need to note is going to be oxygen is always negative 2. Okay, so oxygen is always negative 2. And okay, we know that this is negative 2. So this one must be, because nothing times, so must be 2 plus. So when we name, okay, it's going to be copper. Okay, the oxidation number of copper is plus 2, so 2. Okay, because the number, okay, the oxidation number must be in the middle or beside. Okay, just at the right of the element that we want to write the oxidation number. Okay, copper 2 oxide. Just now, potassium manganate 7, the 7 represents the oxidation number of Mn. Okay, so this one is going to be copper 2 oxide. Rudy, okay, Wilson, okay, Walders, close your laptop, close everything, okay? Taking notes, okay, good. So what you are doing, Waldes? Notes also, but cannot bring laptop to school. Okay, only for CS, okay? Rudy, don't tell me you're taking notes here. Okay, and now only you show, okay, it's okay. Hope you learn something, okay? Same here, Christopher, focus. Now, Cu2O, okay, so first thing is oxygen is 2 minus, okay? And then I want to write for Cu, and that's 2, okay? You require 2. What times by 2 gives you 2 minus? It means this one must be plus. That's why you need 2 Cu plus, so that you get Cu2 plus, okay? Then only plus 2 times by 2, only you'll get plus 2. Okay, so to match this. That's why the 2 came in. Okay, so but originally Cu plus. So we write down as copper 1 oxide. Okay, and what is extra thing that I taught you yesterday? Copper 1 oxide is black. Okay, it's a black solid. Now, if you look over here, similar way that we have learned earlier, which is Fe and O. Oxygen is always 2 minus, nothing times, so it's going to be plus 2. So when I write, it's iron 2 oxide. How about this? Okay, maybe looks a bit complicated. Okay, but always remember, if you memorize this, it will be easier for you, because iron can exist in Fe2 plus, Fe3 plus. There are more, yeah, but the common one, Fe2 plus and Fe3 plus. Okay, Fe2 plus is green. Okay, Fe3 plus is going to be brown. Okay, but this is most likely Fe3 plus. Okay, but if you still want to use this, Fe and O, okay, same method I can just show you. This is 2 minus, okay, and then you need 3. So it means that when I times by 3, you are going to get negative 6. Am I correct? If you have negative 6, this one should be plus 6. Then only they can be the same. How do I get, okay, plus 6? Where I times this by 2. So it means what I times by 2, where I am going to get plus 6. So this value must be plus 3. Then only I'm going to get plus 6. So Fe is plus 3. So this is going to be iron 3 oxide. This is how you write. Yeah. So manganese 4 oxide, vanadium 5 oxide. Now, all these are, okay, I told you, I give you name, and then we write the formula. Okay, and these two examples, manganese 4 oxide, vanadium 5 oxide, they are all catalysts actually. Okay, and what catalyst? Okay, this one, okay, yesterday I told you, okay, there are certain reactions in chemistry, okay, can give you oxygen. Okay, one of the reaction is when you have hydrogen peroxide, H2O2, okay, you add manganese 4 oxide catalyst, and they will give you oxygen and water. Okay, this is called decomposition reaction. Okay, decomposition of hydrogen peroxide, and it happens with the help of catalyst, and the catalyst is manganese 4 oxide. How do I write it down? Mn 4 plus. Okay, and then oxide, oxygen is 2 minus. How do I write the equation? This is 2, this is going to be 4. So this one must be times by 2. So when I write down, it's MnO2. So that's why the catalyst is MnO2. Okay, but the name is going to be manganese 4 oxide. And how do I write down vanadium 5 oxide? vanadium V5 plus. Okay, oxidation number is given by the number itself. Oxide 2 minus. So what do I need to do over here? Kevin? 5 and 2. The common multiply is 5 and 2. Okay, 10. Yeah. So this one you times by 2, you get 10. This one you times by 5, you get 10. So you will have V2O5, the one I circle. Okay, so V2O5, vanadium pentaoxide actually. Okay, but we call it vanadium 5 oxide. Okay, so the name is going to help you to write. The same thing as well, the name is going to help me to write this. Okay, so if I erase this, I should be able to write the formula. Okay, so copper 2 oxide, Cu2 plus, oxygen is 2 minus, so CuO. Copper 1 oxide, Cu plus 2 minus, I must times 2 Cu2O. Okay, you should be able to work forward and also reverse. Okay, iron 2. Iron 2 is going to be Fe2 plus, oxygen 2 minus, so it's going to be FeO. Iron 3, Fe3 plus, O2 minus. Okay, I'm not going to use crisscross, okay, because I know that, okay, I need to get 6. Okay, so this one times 3, this one times 2. Okay, circle, circle, Fe2O3. So I will still get the same thing. Okay, now let's come back over there. So let's look at this equation. So what is going to be oxidized over here? Okay, the one that is going to be oxidized over here, okay, here because, okay, we have calculated copper, yeah, CuO, okay, copper is X, this is going to be -2, and then overall is 0, X is going to be +2. So this is +2. And when you have copper, okay, Kevin, what is going to be oxidation number? Element. Okay, element oxidation number is 0. Yeah. So this is going to be +2 to become 0. There is a decrease in oxidation number. So if there is a decrease in oxidation number, so we say it's reduction. So first I use oxygen. And one of my favorite method to identify something is oxidized or not is by using oxidation number, because this can be used for everything. Okay, and I am always improving. Let's say if you are weak in oxidation number calculation, it's only logical if you keep on practicing it. So don't run away from the problem. So I know I can use the oxygen quite easily. Yeah. But I always practice on the oxidation number. So I hope you can do the same thing. Okay, the same thing over here. Hydrogen, then gaining oxygen is always going to be oxidation. I know, yeah. But you can always practice using oxidation number, because hydrogen, okay, the oxidation number is 0 because it's element. Okay, so this is going to be 0. And what is the oxidation number of hydrogen? Hydrogen in a compound is always +1. No need to even calculate. Okay, it's always +1. So from 0 to become +1, so oxidation number is increasing. Therefore, it's oxidation. So if I ask you, yeah, even though students identify all this correctly, students do still make mistake. Okay, what is the mistake that they do? They identify the oxidized, okay, region wrongly. Okay, so here, what is oxidized? Because They thought CuO to change to give you Cu. They go and give answer copper. Wrong. Or maybe they say we are calculating for copper, I just give copper. No, the answer is this one, CuO. What is being reduced? CuO. What is being oxidized? From here to go there. That's why I always use the arrow. From here, they go there. So, the one that is oxidized is going to be H2. Okay, please answer that correctly. Okay, now, another thing that I want to teach you over here is oxidizing agent and reducing agent. Or, okay, oxidizing agent, you can change the name, okay, which is going to be oxidant. Reducing agent is reductant. Okay, and okay, if you look at oxidizing agent, okay, this one I told you to memorize. Okay, if you have a person, okay, let's say any agent, insurance agent, they are trying to sell insurance. Okay, so they are going to ask you to buy insurance. Okay, in this case, what oxidizing agent will do? They are going to oxidize others. Okay, in the process of oxidation, they will get reduced. Okay, it means that they are going to, okay, oxidize others. Let's say there's another one person, they give the oxygen. Okay, they keep on giving the oxygen, oxidize. But they are going to lose the oxygen. If they are losing oxygen, this is going to be reduced as well. So, oxidizing agent is going to oxidize others. Okay, I'll just put oxidize others. But at the same time, they are losing the oxygen. Therefore, they get reduced. This is very important. So now, from this equation, first of all, is this a redox reaction? Yes. Okay, there is oxidation, there is reduction. And from this equation, we can find what is the oxidant, what is the reductant as well. Okay, so the oxidizing agent, something that oxidizes others, but they get reduced. Which one get reduced? CuO. This is the oxidizing agent. So CuO is going to oxidize hydrogen. Okay. What is the reducing agent? The reducing agent over here, something that will reduce others, but they get oxidized. So, reduce others and get oxidized is going to be hydrogen. So, it means that hydrogen is going to reduce CuO. Actually, that is the real reaction that is happening. This reaction is known as reduction reaction by using hydrogen to reduce copper oxide to become copper. Okay, this is one of the reaction where, okay, when you want to purify or extract copper, okay, from the soil, okay, you get copper oxide, and you want copper only, okay, you can use the hydrogen, okay, and then you can get the copper. Okay, this one is called reduction of copper or extraction of copper metal, okay, from its ore. Ore means something the impure form. Okay, you try to get the copper. Okay, so we use hydrogen, but we can only use hydrogen, okay, for extracting certain metals only. In this case, hydrogen is more reactive compared to copper. That's why you can do that. But if you want to extract aluminium, you cannot do that, because last time you learned under reactivity series, aluminium is at the top, okay, hydrogen, then followed by copper. Okay, the reactivity series, okay, if you have aluminium here, hydrogen over here, copper over here, hydrogen is more reactive than copper, you can do, okay, the reaction. And this is the same method when I taught you about the electrolysis yesterday. okay, where I said if you have H plus and copper 2 plus, which one will be selected? The one that lower will be selected. Copper 2 plus will be selected instead of hydrogen. But most of the cases, hydrogen will be selected. Okay, but in this case, aluminium is more reactive. Okay, so for hydrogen, you cannot use hydrogen to extract or reduce aluminium. Okay, this one we will learn later. Okay, in IGCSE, you would have learned extraction of aluminium is done using electrolysis method also. Okay, so that is some extra knowledge for you. Okay, but okay, even in JC2, we don't go into detail about it. Okay, because extraction, okay, like for example, I hope you learn all this, extraction of iron, okay, you use iron, you get it in form of bauxite, okay, where you extract by using carbon, or they call it coke, okay, and then carbon you can use to extract Fe, okay, so that's why you have different ways of extraction. Okay, for copper, you can straight away use hydrogen, okay, but hydrogen is not suitable for everything, okay, that's the reason. Now, I'll go through very quickly about yesterday's assignment. Okay, I hope you have tried. Okay, so you have, okay, two main oxidizing agent in our lab. Oxidizing agent, yeah. So KMnO4 and K2Cr2O7. Both are oxidizing agent and they will only work if it is going to be acidified. Okay. Now, always remember, if they are successful, okay, in oxidizing others, the color change is going to be purple to colorless. And the color change over here, okay, is going to be orange to green. OG. Yeah. So orange to green. Okay. So you just need to know the observation, okay, and how to write the half equations and how to write the complete equation. So let's say I am using both of these oxidizing agent to oxidize Fe2 plus to become Fe3 plus. Okay. So my equation, okay, this is going to be my first equation. And let's say I'm going to use this. So I'm not going to include K, okay, straight away, half equation, MnO4 minus, okay, so I'll just use MnO4 minus to become something. And I will write down here Fe2 plus to change into Fe3 plus by using Cr2O7 2 minus to become what? Yeah. Yesterday I have showed you, okay, the equation for this. Okay. MnO4 minus, this is going to be purple. The colorless is going to be crystal. MnO4 minus will change into Mn what? Joyce? Don't know, yeah. Yesterday, yeah. 3 periods. Mn2 plus. I told you to memorize this. Yeah. And, okay, here, Cr2O7 to minus, they will change into Cr3 plus. Once you know this, you can do everything already. Okay, this is going to be orange, this is going to be the green. So now, I want to write down the half equation. This is losing one electron, so plus electron. Here, oxygen, there's no oxygen, and I told you, in chemistry, there are limited, okay, chemicals that can give you oxygen. So you are not going to get O2 over here. You are going to get in form of water. Okay, so there is no hydrogen on the left. So you need to include the hydrogen in form of H plus. That's why it's acidified. Okay, the rest, okay, you balance it. That's 4. Okay, so I put 4. Hydrogen is going to be 8 now. So I put 8. And the last part is to balance the charge. The charge over here is plus 2, 0, so total charge is plus 2. The charge over here is negative 1. This is 8. Okay, negative 1 plus 8 is plus 7. Okay, so how do you change to the same charge? By adding 5 electron. Okay, so negative 5, so you get plus 2. Same. Okay, so once you have done that, you just need to eliminate the electron. So eliminate the electron by times by 5 electron here. So times by 5, you add. When you add, the 5 electrons will cancel, left and right. So you have 5 Fe2 plus, MnO4 minus, plus 8H plus, 5 Fe3 plus Mn2 plus 4 H2O. Okay? And then, let's actually do the same over here. This is my work yesterday that I asked you to try. Okay? Now, lose 1 electron, so you put like that. And now here, must memorize this. Okay? So you have 2. So first, put 2. Okay? Next, there is oxygen. You are not going to get O2 here. You will get H2O. So here, you put hydrogen, ion. Okay? Now you balance. How many oxygen? 7. I just put 7 over there. How many hydrogen? 14. So I put 14 there. So now you balance the charge. 2 times 3 plus 6, 0. Okay. Here, 2 minus and then 14. So you will get 12. How to make it the same? Left and right. You add 6 electron. So you plus negative 6. You will get plus 6, plus 6. Okay. Next, you just need to balance the electron. Times everything by 6. Okay. 6 electron and 6 electron will cancel. And you just need to rewrite it again. This can be applied not only Fe2 plus to become Fe3 plus. You can change it. Okay. Let's say, for example, Cu plus to become Cu2 plus. Okay. Anything that involves oxidation. And then they will ask you to write, yeah, the half equation and so on. Now, I have 1 copy each. Not each, yeah, each table. Okay. Want you guys to discuss. Okay. Both of you share. Yeah. Maybe share. I want 1.